I'll give you all credit for it. Was that you, Jessica? It was you. Trend.
I can't even take the credit for that.
Well, I'm going to give you credit. I was just point to you. Jessica used the word trend earlier. Trending. When you look for a trend, that can be dangerous, but in this case, I think it's very, very good. That means your mind is already looking for a pattern, right? A trend is like a pattern. You're looking for something that's repeating itself. That's very, very good. It might not always be a consistent repetition, although in this one, I think it's fairly consistent. It looks to me like there's a trend going this way. So, we've got a basic idea. We've got a general idea. And what you want to do when you mathematically model is you want to go from a general idea to a specific model. So you start with a general overview. And this, friends, is where the scatter plot comes in so handy. Because you open the scatter plot, you take a look and you go, okay, what is it generally doing? Generally, it's going up as we go left to right. Good, good. How is it going? It's going up as we go. Jury, please go.
Really fast, when you're creating a line to match them all up, isn't it a line of best fit?
Yes, ma'am, and we're getting there. Because what you've just done, Jury, thank you for the segue.
Sorry.
No, why are you sorry? It's awesome. Once you've arrived at your general consensus at what you're looking at, then you get specific. You get into the specific model. So next week, when we go out on that hill with my bike, and you guys track me going downhill on my speeds and my times, it might be a different model than the model right here. And it might be a different model than the Mount Bachelor ticket prices we'll analyze momentarily. And it might be a different model than our forearm measurements that we're going to measure, hopefully by the end of class today. These all might be different models. But the idea is, look at the data first and see if the model jumps out at you. Once you can say, like, okay, it looks like this kind of model, then you can apply mathematics to get that kind of model. So, can we come to ish an agreement that this looks pretty good, pretty much like a line? It's not perfect. It never will be, just so you know. It never will be perfect. It can't be. If the data's perfect, I think I gave you this warning. This is why Harrison Ford was running from the one-armed man. Because the data was too perfect. Remember what they did? They took the slides out, and they replaced they were liver cross sections. And I'm giving some of the movie away if you haven't seen The Fugitive. But there was a science experiment done for a new drug. I forget the name of the drug now. I can see it. I can see him talking about it as he walked through that room. But they took the real slides out, which were messy. They were like this. And they put new slides in where it did this. And the drug company was like, hell yeah, that's fantastic. And Harrison Ford was like, hell no, you're going to kill somebody. Because I know what the real slides look like. And then they had to try to kill him to keep him quiet. Anyway, that's the gist of the movie. It's still a great movie. You should watch it. But that's the idea. Data will be noisy. And this is why I go back to what Chrissy said, because data's noisy, but this is predominantly a line that does this. Now, if I saw data that did this, ish, I wouldn't call that a line, because it's got too much of a curve to it. It's got too much of a curve to it. Likewise, and we're going to see all this data. I got plenty of data sets for us to play with in this class. Plus, if we saw something that was more like this, okay? This is the old, if your head's in the oven and your feet are in the fridge, on average, you're fine. You can find a line that describes that, but it's not a very good description of that. That would be more of a periodic description, like temperatures during the day. Okay, we have time we'll analyze temperature data too. But this, when I look at this, and this is something you're going to develop over the course of this class, I see roughly linear data. It's not perfect, it's close-ish. That three-letter suffix you'll learn well in this class too, ish. It's linear-ish. It's linear-ish. And you guys proved this point yesterday by looking at slopes. You kept creating successive slopes and realizing that they're right around the same. Good, right around the same. So now the question is, if we're happy that it's linear-ish, Jury has already given us kind of an